So in this video, we're going to talk about the mass percent for determining the empirical formula. And the idea is that what if you're given you're given a list of elements and they're broken down into their corresponding percentages. How can we determine the empirical formula? Okay, and for these types of problems, what you got to do is assume you have 100 grams of the compound. Okay, now I have nicotine here, and it's broken up into its different substituents. So how can we determine the empirical formula? Well, the idea is that you got to assume you have 100 grams of the compound. So what does that mean? In short, what that essentially means is that these percentages actually correspond to the amount of grams of the compound I actually have. And so we could put an equal sign here. We could put an equal sign here. We could put an equal sign here and say we have approximately 74.03 grams of carbon. We have approximately 8.70 grams of hydrogen, and we have approximately 17.27 grams of nitrogen. Okay, so that's what we mean by you got to assume you have 100 grams of the compound. Okay, and if you look at this, they should be roughly, if you add these up, they should be approximately 100 grams of the compound. Now, based on what we know from the beginning, what we need to do now, since we have the grams of the compound, we need to go to moles. And so if I start with carbon, I have 74.03 grams of carbon, and using carbon's molar mass, well, from the periodic table, we know that for every 1 mole of carbon, I get approximately 12.011 grams of carbon. Okay, and notice that grams of carbon cancel out to just give me moles. And so when I divide 74.03 by 12.011, I should get approximately 6.164 moles of carbon. Okay, now I'm gonna do hydrogen next. So if I have 8.70 grams of hydrogen, using the periodic table, I know that for every 1 mole of hydrogen, I get approximately 1.008 grams of hydrogen. Okay, again, notice that my grams on the bottom, grams on the top will cancel, just give me moles. And if I divide those, I should get approximately 8.631 moles of hydrogen. I'm going to do the same thing for nitrogen. So we have 17.27 grams of nitrogen. Okay, from the periodic table, we know that for every 1 mole of nitrogen, we get approximately 14.007 grams of nitrogen. Okay, notice again, grams and grams cancel out, they only give me moles. And so when I divide these two numbers, okay, I should get approximately 1.233 moles of nitrogen. Okay, so this is a process. And now what becomes apparent is that now I take the least amount of moles, the number that gives me the least amount of moles, and I divide all the number of moles by that number. So starting with carbon, we have 6.164 moles of carbon. I'm going to divide that by the lowest number, which happens to be 1.223. Well, 233 out of all these numbers. So if I divide that by 1.233, let's put that in my calculator. So if I divide 6.164 divided by 1.233, I should get about 4.99, but again, 99 moles of carbon. But again, we know we can't have 4.99, so we got to round this up to 5 moles of carbon. Okay, now I'm going to do the same thing for hydrogen. So I'm going to take 8.631 moles of hydrogen. I'm going to divide that by 1.233. Okay, and when I do that, so 8.631 divided by 1.233, I get approximately 7 moles of hydrogen. Okay, and for the last one, I'm going to say the same thing. Obviously, anything divided by itself is just 1. So I'm going to take 1.233 moles of nitrogen, and I'm going to divide that by 1.233. And obviously, you can see that this will give us 1 mole of nitrogen. Okay, so in the last step, all we do is just take the elements and just combine them into its corresponding empirical formula. So in this case, we have 5 moles of carbon, so this is C5. We have 7 moles of hydrogen, so this is H7. And we have 1 mole of nitrogen, which is N. And this would be the empirical formula.